GSD3 is a disease that lacks the amino 1,6-glucosidase known as glycogen debranching enzyme. Usually, the debranching enzyme helps mobilize glucose as a part of glycogenolysis. However, the lack of this enzyme leads to phosphorylase can only degrade glycogen branch point, which is the alpha-1,6 linkage, and no further, leading to the glucose residues cannot be released, and abnormal glycogen will be accumulated in the liver and muscle. Both sides on the enzyme with the phosphorylase and phosphorylase kinase enzymes are responsible for glycogen breakdown to raise blood sugar. With a normal debranching enzyme, two things happen. If glycogen can only be broken down partially, an insufficient amount of glucose can be produced. The structure that is left, resembling a molecule called limit dextrin, is excessively accumulated in the liver and in muscle tissues. Gluconeogenesis is actually intact in this disease because the body still has the ability to convert glucose 6-phosphate to glucose from other sources such as from lactate and glycerol. Recessive genetic disorders happen when a person inherits two copies of an altered gene of the same trait, one from each parent. If an individual inherits one normal gene and one gene contains the disease, the person will be a carrier for the disease but usually shows no symptoms. The risk for two carrier parents to both pass the altered gene leads to an affected child. GSD3 is the result of a mutation in the AGL gene that is located on chromosome 1p21. The AGL gene is responsible for the production of the debranching enzyme. Most of the mutations are caused by a nucleotide substitution or small insertion or deletion. Mutations in the AGL gene can affect different isoforms of the enzyme depending on the location. For example, mutations can occur in a part of the AGL gene called exon 3, affects the isoform that is primarily expressed in the liver.